Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss transverse nature of plane electromagnetic waves. Let's begin. First, we have to understand what is transverse nature. Let us consider the coordinate system. Coordinate system as x, y, z. Y direction for electric field, z direction for magnetic field intensity. Electric field oscillates in that of y direction and magnetic field on that of h direction. Therefore, the direction of propagation of electromagnetic waves along x direction. That direction of propagation of electromagnetic waves we show in that of k vector. That is the wave vector. E vector which oscillates perpendicular to that of propagation of wave vector. H vector E vector red symbol I used for S vector. That electromagnetic wave is said to be transverse in nature, means that electric field, direction of that electric field when perpendicular to the direction of that of wave vector, and the direction of S vector is perpendicular to the direction of k vector, then we say that plane electromagnetic wave is transverse in nature. When E vector and k vector are perpendicular with each other, mathematically if the dot product of E vector and k vector is 0, again if the dot product of S vector and k vector will be 0, then we can say E vector is perpendicular to k vector and S vector is perpendicular to k vector. Consequently, that plane electromagnetic waves is said to be transverse in nature. Let us proceed. Let us consider the plane electromagnetic wave propagates through vacuum or free space. Anybody can take the propagation of plane electromagnetic wave in a dielectric medium, no problem. We here consider the propagation of plane electromagnetic waves through vacuum or free space. Then the wave equation for electric and magnetic field is given by we have already derived for electric field grad square E vector minus 1 by c square del square E by del t square is equal to 0, and for h vector grad square h vector minus 1 by c square del square h vector del t square is equal to 0. These two. The solution of that type of wave equation, the general solutions in the top form for E vector, that is position r and time coordinate t in the top 3 dimension, given as E vector, that one is the amplitude e to the power I k dot r minus omega t, and same for that of h vector r t h naught e to the power I k dot r minus omega t. The solution of that type of wave equations. Here k that is the propagation constant, or we can say it as wave vector. And it is given as k vector as I cap kx j cap ky plus k cap kz, and for r vector, that is the position I cap x j cap y plus k cap z. Then k dot r, dot product of these two, that is given as kx x ky y plus kz z. To show the dot product of E vector and k vector as 0, first we have to derive what is gradient of E vector. Now gradient of E vector. So gradient for E vector E naught e to the power I k dot r minus omega t is equal to E vector, the gradient of e to the power I k dot r minus omega t. Grad is an operator, and that operator in that of Cartesian coordinate, as we consider in 3-dimensional Cartesian coordinate, that operator written as I cap del by del x plus j cap del by del y plus k cap del by del z, which operates over that of e to the power I for k dot r kx x ky y kz z minus omega t. I cap del by del x to that of e to the power I something. That term then it differentiate with respect to that of x. So, we obtain overally that term as common, and differentiating it we have e naught vector. When differentiating it we have I cap for del by del x I into kx x, that one as I kx. So, for another terms j cap I ky plus k cap I kz. As you differentiate that entire term with individual terms, so we have that term as in that of outside, which is equal to I e to the power I. Now we write its original form k dot r minus omega t is equal to, in that bracket term, each term contains I to that of outside. The terms are written as I cap kx, j cap ky plus k cap kz into e naught e to the power I k dot r minus omega t is equal to I, that one is k vector into this term as we say e vector. So, here we obtain grad dot e vector is equal to that one. Similarly, when we taking that divergence of that s vector, means grad dot s vector, we can obtain grad dot s vector, that is I k vector dot s vector. From these two equations, we have e vector cancelled out. So, the grad operator is equal to I k vector. Instead of grad operator we can use I k vector. Now, proceed towards Maxwell's equations. from Maxwell's equation, Maxwell's first equation, grad dot d is equal to rho. For vacuum, as we consider that plane electromagnetic waves propagate through vacuum or in free space. So grad dot in place of d, epsilon E vector, here rho will be 0. As we say, for vacuum, charge density 0 and d vector epsilon E. Therefore, grad dot E vector is equal to 0. In place of grad, we can use I, k vector dot E vector as 0. Therefore, k vector dot E vector as 0. So, on equation number I. Then from Maxwell's second equation, divergence of that magnetic field will be 0. Again, in place of B, that is mu H vector is equal to 0. Therefore, grad dot H is equal to 0, or in place of grad operator, I k vector dot H vector as 0, or k vector dot H vector is 0. That is equation number II. Look here, dot product of two vector is 0. Then the angle between these two vector ultimately 90 degree. So, angle between k and E vector 90 degree, angle between k and H 90 degree, angle between k and E 90 degree, angle between H and k 90 degree. So, we can say that the plane electromagnetic waves are transverse in nature. Important point we write here. Hence, it is obvious that both the electromagnetic field vectors, that is E vector and H vector, are perpendicular to that of k vector. Which one is the direction of propagation vector? Perpendicular to the direction of propagation vector, that is k vector. Consequently, we can say, electromagnetic field vector E vector H vector is nothing but electromagnetic waves. Consequently, the electromagnetic wave are transverse in nature. The electromagnetic waves are transverse in nature. We can mathematically show it by using Maxwell's equations and the equations for that of electromagnetic waves. So, here with the help of this video lecture, we understand the concept of transverse nature of plane electromagnetic waves. First, we have to consider that the plane electromagnetic waves is propagating through that of vacuum or in free space. Then we write the equations for electric field and magnetic field and its solutions, taking divergence of that electric field, we can show that del operator in that of form of ik vector using Maxwell's first equation and second equation. We show the electromagnetic field vector E vector and S vector are perpendicular to the direction of propagation of that vector k vector. Therefore, we can easily say that electromagnetic waves are transverse in nature. So, with this useful and informative notes, let me wind up the session. Thank you.